Okay, girls, just to recap, we're going to talk about graphing in slope-intercept form, and the things I want you guys to focus on are the following. So being able to identify the slope of an equation that's written in slope-intercept form, being able to identify the y-intercept when it's in slope-intercept form, and then of course using those ideas and graphing the equation. Then we're going to go on to graph multiple equations on the same Cartesian plane. That's just secret for graph. So we're going to graph more than one equation on the same graph. And then we're going to be able to look at the graph and tell what the equation of the line is. So we're going to identify the equation of a line on a graph. So if I give you this, you tell me what the equation of the line is. So I just wanted to review that with you. Those are our goals. Okay, so we talked the other day about slope-intercept form. You have this in your notes. Y equals mx plus b. M was the slope. B was the y-intercept, where it crosses the y-axis. And then I asked you guys to describe how you can tell what the slope is from the equation and how you tell what the intercept is from the equation. And so what we came up with was a few things. We said slope is what x is multiplied by, or we said it's the number next to or in front of x. But we have to be careful about that because sometimes if that number is 1, we might not always see that number. So, and then the y-intercept, we can tell it's just a number, right? Remember we talked about that? It's just a number that's added or subtracted. Blech. Added or subtracted to the x term. So sometimes it'll be positive, sometimes it'll be negative. Okay, so where we left off is we started talking about the steps for graphing in slope-intercept form, and I want you to write these steps down in your notes. The first thing that we're going to do is plot the y-intercept on the vertical axis. Remember, vertical is the one that goes up and down. Y-intercept, that is the b in the mx plus b form. So that's the first thing we're going to do. Once we do that, then we're going to use the slope to plot 2 more points, and that's an at least 2 more points. I'd like you to plot as many as you can fit on your graph. And then, of course, we're going to connect all of those points using some sort of straight edge. Okay, so let's look at this example and follow the steps. The first thing we're going to do is plot the y-intercept, the b term. So if we think about this in y equals mx plus b, you can see that the b is 3 and the slope m is 1/2. So 3 is where it crosses the vertical axis, the y-axis. So we go up 1, 2, 3, and we plot that point. Now, in step 2, we use the slope to plot at least 2 more points. So my slope was 1/2. Remember, slope is rise over run. So from this point here, the 3 on the y-axis, we're going to rise 1 and run 1, 2, 3. And then we could do that again. We could rise 1 and run 1, 2, 3. Okay, that gets me off my graph here, so that's a little funky. And instead of that, we could also go backwards, right? Down 1 and back 1, 2, 3. And that gives me slope that's going in the exact same direction. So now we've got lots of points on our graph. And what we do is we get our straight edge and we connect all of those points with a nice straight line. And they should all sit on exactly the same straight line, right? Okay, so let's do another example together. If we think about this in the form of y equals mx plus b, the equation is y equals 2x minus 3. So in this case, b is equal to -3 and m is equal to 2. So first we'll start with the slope, or excuse me, the y-intercept, -3. So we'd go down 1, 2, 3 on the y-axis. Now my slope is 2, and that's rise over run. And so remember, anytime we have a whole number, we think about that as over 1. So from here, I'm going to rise 2, and I'm going to run 1. So up 2, and to the right 1. Up 2, to the right 1, up 2, to the right 1. And look, it's really fast, really easy for me to get lots of points on here. So when I connect them with a nice straight line, I know my line's going exactly where it ought to go. Okay? And that's it. How easy is that? So now I want to connect this to what we were talking about the other day. If we have this equation that's in slope-intercept form, y equals mx plus b, how can I tell if the point -1, 1 is a solution to the equation? What are two ways that we could figure out the answer to this question? Alright, well, think about that for a second, and then we'll talk about it. But think about it for a minute. Okay, so one way is I could plug in the point into the equation. So in this case, since the point is -1, 1, those are x and y values, I could plug in x equals -1 and y equals +1 into the equation, y equals 3x plus 2. So let's go ahead and do that. My y value is going to be 1, and that's going to equal 3 times my x value, which is -1, plus 2. So we simplify that. So we get 1 equals 3 times -1 is -3, -3 plus 2, and then -3 plus 2 is actually -1. 1 does not equal -1, so we know that it's not a solution to the equation. So that's one way, right? Plugging it in. The second way we could determine whether that point was a solution to the equation. We could graph it. We could see, is the point -1, 1 on the line? If it is on the line, it's a solution to the equation. If it's not on the line, it's not a solution to the equation. So let's get ourselves a little graphy graph here. There we go. Maybe make it a little bit smaller for us to work with. Okay, here we go. Alright, so let's take a look at that equation. The equation was y equals 3x plus 2. So I can see that my y-intercept, my b value is 2, and my slope is 3, or 3 over 1. So graphing that, I'm going to go up 2 on the y-axis, and then use my slope to plot more points. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1, and I'm kind of out of room here, so I'll go backwards, down 1, 2, 3 over 1, down 1, 2, 3 over 1, and that looks pretty good. So now we'll connect the dots. So there's the graph of the equation. Remember, this line is y equals 3x plus 2. And what we're looking for is the point -1, 1. Well, -1, 1 is back 1 in the x direction, up 1 in the y direction, so that point is right here. So -1, 1 is not on the line, so again we know it's not a solution to the equation. Okay, so since we finished the notes, you need to do a few things. Number 1, make sure that you have all of the notes. They're not very many. They weren't very long. You can get all of the examples, all of the work in your notes. Number 2, we took this on Avid paper, so I want you to go back and fill in your questions that go in the left-hand column. You should have some level 1, some level 2, and if you really want to stretch, let's go for some level 3 questions. But really, let's focus on these 2 levels right now. Make them very specific so you could tell exactly what you were talking about if you read those questions, 3 weeks from now. And then the third thing, of course, I want you to do is your summary. After this, you're going to get to do some practice graphing in slope-intercept form, but I really do want you to do all 3 of these things first. Okay?